Okay, so we've talked about dot diagrams. Now let's translate those into graphs of position versus time. So on a dot diagram, all you see is the change of x every second, denoted by a dot that's dropped every second. And so in this particular example, the red car is traveling at a constant speed, and the blue car is traveling and getting faster. So just looking at the dot diagrams, the red car I can tell is going at a constant speed because its dots are equally spaced. And it's got a constant speed of 5 meters per second. So every second it increases its speed of 5 meters per second. The blue car, on the other hand, has an acceleration to the right, which means that since it's moving to the right, it's going to speed up. And you can see that because the dots get further and further and further. So let's translate that to a graph. So now if we were to, instead of just doing like a one-dimensional graph, we were to look at both dimensions, position on the x-axis and time on the, position on the y-axis and time on the x-axis. So after 1 second, the red car has gone 5 meters. After 2 seconds, it's gone 10 meters. After 3 seconds, it's gone 15 meters. After 4 seconds, it's gone 20 meters. And you see that the line is linear because it goes the same distance every instant in time. 5 meters, it rises 5 meters every second. So its slope is constant for constant velocity, and the slope is the rise over the run, meters per second, or 5 meters per second. But look at what's happening to the blue one, right? The slope is not the same. I can see that. It starts out pretty flat, and then it gets steeper and steeper and steeper. And it turns out that that slope is increasing by the same amount every instant in time because its speed is increasing by the same amount every instant in time, which we said is 1 meter per second every second. So at 1, it has a speed of 1 meter per second, or a slope of 1 meter per second. At 2 seconds, it has a slope of 2 meters per second. At 3 seconds, it has a slope of 3 meters per second. At 4 seconds, it has a slope of 4 meters per second. And all the way up here, at 10 seconds, it has a slope of 10 meters per second. And at 14 seconds, it has a slope at that instant of 14 meters per second. So slope is rising, and it turns out that that is the definition of a parabola. This is a quadratic equation. So for an object that's undergoing constant acceleration, that means it's changing its velocity by the same amount every instant in time. The position graph is going to be a parabola. And for an object that's undergoing constant velocity, the position graph is going to be a line, and the slope of that line is going to be equal to whatever the speed is. If it's a positive slope, it's moving in the positive direction away from the start point, and if it's negative, it means it's moving in the negative direction. So let's just take a look at that. Let's look at a little bit different situation. What if we had a car that had a negative, actually we can't do that. So never mind, we're not going to do that. We'll talk about that in the next video.